Hello. Today we can solve, as shown, questions from the chapter complex numbers. Okay, it was asked in 2018 Keam examination. Okay, 9 questions were asked in that year. Let us see the questions. The area of the triangle in the complex plane by Z, IZ and Z plus IZ. It is a result actually. Area of triangle whose vertices are at, Z, IZ, Z plus IZ is half mod Z square. So it's a formula, it is a result which you should always remember. Okay. So answer for that question is option C. Now we come to the next question. Set 1 is equal to 2 minus I, set 2 is equal to 1 plus I. We have to find out mod Z1 plus Z2 plus 1 divided by mod Z1 minus Z2 plus 1. So mod Z1 plus Z2 plus 1 divided by Z1 minus Z2 plus 1. We substitute for Z1 and Z2. Z1 is 2 minus I. Z2 is 1 plus I plus 1 divided by, in the denominator, 2 minus I minus 1 plus I, then plus 1. Now simplify the numerator. 2 plus 1 plus 1. 3 minus I plus I is getting cancelled. And the denominator, 2 minus I, 2 minus 1 plus 1. So it is 2. Numerator we have got 2 plus 1 plus 1, it is 4, I think. Okay, there is an error. Here it is 4. Okay. 4 divided by 2 minus 1 plus 1 is 2 only. Then minus I minus 2I. Okay. Now it is very easy. You take the modulus of the numerator and also the modulus of the denominator. Modulus of mod 4 is, modulus of 4 is 4, denominator root of 2 squared 4 plus 2 squared 4, which is equal to 4 divided by root 8. Root 8 is 2 root 2. It is equal to 2 by root 2, which is equal to root 2. Simplification. So answer for that question is root 2, that is option B. Now the third question. Given that a plus ib whole raised to 11 is 1 plus 3i. A plus ib whole raised to 11 equal to 1 plus 3i. Now, what about the conjugate of a plus b whole raised to 11? So a minus b whole raised to 11 is equal to, it will be 1 minus 3i. Why? Because imaginary parts, the sign will change. Real part sign will remain as it is. That is why. So a minus IB whole raised to 11 is 1 minus 3I. Now, you are being asked to find out B plus IA whole raised to 11. B plus IA whole raised to 11. Okay. So we have got A minus BI and A plus BI. No problem. We take I as a common factor. So I into, so here it will be A minus IB the whole raised to 11. Okay. So this is equal to I raised to 11 into A minus IB whole raised to 11. What about I raised to 11? I raised to 11 is I raised to 8 into I cube, which is equal to minus I. So here it is minus I. A minus IB whole raised to 11 is equal to 1 minus 3I. We have already calculated and it is there in equation 1. Okay. Now you multiply minus I into 1 is minus I. Minus I into minus 3I. Again, you are getting minus, is it not? Minus 3. So minus I minus 3. Yeah, it is there in option E. Yeah, correct. Minus I minus 3. Actually, we have to write it in the standard form, that is minus 3 minus I. No problem. Whatever is there in the option, we have got it. Now let us go to the fourth question. Z is equal to e raised to I pi by 3. E raised to I pi by 3. Now, Euler's theorem, e raised to I theta. What is it? It is cos theta plus I sin theta. So e raised to I pi by 3 is cos pi by 3 plus I sin pi by 3. Okay. You are being asked to find out Z raised to 1 by 2 plus Z raised to, 192 plus Z raised to 194 whole cube. Let us first find out Z raised to 192 is equal to cos pi by 3 plus I sin pi by 3 whole raised to 192. It is equal to cos 192 pi by 3 plus I sin 192 pi by 3. What is cos 192 pi by 3? That is cos 64 pi plus I sin 64 pi. Okay. What is cos 64 pi? Even number into pi, it is 1 plus I sin 64 pi, sin even number into pi is 0. So it is equal to 1. Okay. Now what about Z raised to 194? Z raised to 194 is equal to cos 194 pi by 3 plus I sin 194 pi by 3. So we have to simplify. This is equal to cos 65 pi plus pi by 3. This minus, I think. Yeah. Minus pi by 3 plus I sine again 65 pi minus pi by. Now the question is, what is cos 65 pi? Now 65 pi, it is an odd number into pi, minus it is coming in second quadrant. Second quadrant, by using ASTC rule, cos is negative. So it is minus cos pi by 3. Sin is positive, plus I sin pi by 3. Now what is the question? The cube of z raised to 192, okay, plus z raised to 194, the cube of this, which is equal to z raised to 192 is 1 minus cos pi by 3 plus I sin pi by 3, the whole cube. Now you know the value of cos pi by 3. Cos pi by 3 is cos 60, that is 1 by 2. And I sin pi by 3, sin pi by 3 is root 3 by 2. The whole cube. So 1 minus 1 by 2 is 1 by 2. Okay. Plus I into root 3 by 2, the whole cube. Again, we can use de Moivre's theorem. Now, 1 by 2 is nothing but cos pi by 3. Plus I sin pi by 3, the whole cube. De Moivre's theorem, it is cos pi, 3 into pi by 3, plus I sin pi. Cos pi, you know it is minus 1. Sin pi is 0. So the answer is minus 1. So the solution is a little lengthy. So answer for this question is minus 1. Okay. One more question we can do in this video. Okay. The modulus of 1 plus I by 1 minus I. So that Z is equal to 1 plus I divided by 1 minus I minus 1 minus I divided by 1 plus I. Now result, 1 plus I by 1 minus I is I, and 1 minus I by 1 plus I is 1 by I. So which is equal to I minus 1 by I is minus I. So which is equal to 2I. Therefore, modulus of Z is equal to modulus of 2I. It is equal to mod 2 into mod I. It is equal to 2, because mod I is equal to 1. Okay. Okay, remaining questions from this chapter I'll be doing in the next video. Okay, thank you.